Uh, as you already know, since an introduction has been made, Professor Sakri is the patron of INSA Asia network, and he has been in the field for a long time, and I'm sure it'll be very useful to share his experience, to learn from his experience. Thank you. Over to you.
Thank you, Professor Nadira. Thank you very much for having me during this conference. After being here last night, I've changed a bit my presentation because I know there's a lot of experience around the room on science governance. I'd like just to focus on the main event of your two-day conference, and that would be on science advice. So science advice, from my perspective, is not exactly from the strictly academic scientific perspective, but more so on the linkage between the scientific community, in particular, the National Academy of Sciences, like what we have here today, and how you would link with the policy community, in particular, the politicians. So I would be speaking from quite a substantive experience in this as science advisor to the Prime Minister of my country a few years ago, being a member of the Scientific Advisory Board to UN Secretary General Mr. Ban Ki-moon, and a host of other experiences. Like what I told you last night, I'm a strict academic at one stage, but I graduated to be a so-called science diplomat. Let me go very quickly. So let us ask this question: why is science advice so critical today? Underline advice, science advice, and not really science per se. And that is because science advice contributes to solving global challenges in sustainability. And we know the three areas of concern today would be climate change, biodiversity loss, and microplastic. It is a global problem. It is also a local problem. And how science advice come into being is the fact that science, technology, and innovation holds the key to overcoming those challenges. So it is looking at you to contribute to these challenges. On the other hand, as we also know, scientific advancement has been progressing very rapidly. One case in point is the fourth industrial revolution, and here, or industry 4.0. And here again would be the role of science advice. For most of us, in fact, in the global south, some of us are even only on the second industrial revolution, it's not even third, and let alone fourth. But we cannot be left behind. So we need science, the scientific community, advances in science and technology to advise our policymakers, our politicians, how we can cash in on the benefits of the fourth industrial revolution. And of course, finally, how the scientific community rise up to the occasion of responding to the Sustainable Development Goals, which had been agreed by leaders in 2015 during the Millennium Summit, with the goals of achieving the 17 targets by 2030. 30. And this is easier said than done. But if you look through in all those targets or goals, science, technology, and innovation is the underpinning to solving some of these problems, ranging from poverty alleviation to all the others, to all the other targets here. I'll just touch very briefly on science governance, which I hope all of you would notice. Yeah, this eventually is the architecture of science advice in any country. It's almost idealistic, but in many countries, in particular the industrialized countries, they have all these elements. So preferably, science advice eventually should reach to the desk of the president or the prime minister, because he's the numero uno of the country. But below that, there should be all this, like, for instance, the relevant ministries, in particular MOSTI, Ministry of Science, Technology and Innovation. But it is not only the purview of this ministry. In fact, in all countries, as you can see from here, there'll be many more ministries involved. And if you are not careful, these ministries would behave in silos. And eventually, the left hand doesn't know what the right hand is doing. So big, big trouble. Those are the formal government structure. But beyond that, there would be, of course, the Academy of Sciences in each country, which would also constitute a key component of the governance of science advice. But in many cases, sometimes National Academy of Sciences are contented, or sometimes they are not able to reach to the powers that be, the policymakers and the politician. And this is where, again, the science policy linkage is key. In many countries, there's a so-called National Science Council or Council on Science and Technology, which you would find in many countries, which would advise the Prime Minister. In some countries, like mine, they have an individual as a science advisor to the Prime Minister. So, ladies and gentlemen, what are we doing in all of this? Just to share with you again the ultimate goal of science advice. And this I got from serving my Prime Minister. The politician, the Prime Minister, normally is a very simple man. What he told me, it doesn't matter what kind of science advice that you would want to provide us. But to me, as a Prime Minister, he said, I want two things from you. Number one, can the science advice that you impart would provide jobs, more jobs and jobs, right? Secondly, can this science advice translate into better socioeconomic position of the people, in particular the bottom 40? So these are very simple, but you see here, if Academy of Sciences eventually could not connect and reach out to those two targets that politicians would request us, then your R&D may not be as relevant as one would want it to be to any country. Life goes on, of course. You get promoted. If you're in the university, you become professors. If you're in the research institute, you become the director general and whatnot. But all the same, the bottom line for any country is socio-economic advancement of its people. So let us now look at what the science policy nexus is all about. Number one, this advice is informing or influencing policy through evidence. And that evidence would be obtained from the R&D that we'll be doing in our research institutes and universities. And that advice is not simply providing policymakers and politicians with factual results of research, but to make sure that these results are applied to policy deliberations and decision. What it means here is the advice must be taken up by the decision makers. So science and policy making are very distinct cultures, as you know, and there's a lot of societal values between science and policy making. So there would be an overlap, and as you can see from, now I need to go back. How do I go back? Hasmila, can you help me? I need to get back to the third slide. All right, okay, this one, the diagram. So you see that boundary function. Eventually, science has to work out with the policy community, with the facilitation of society to effect that impact. So, ladies and gentlemen, which, as we know very well, virtually every challenge governments face has a scientific dimension, which may or may not be recognized. And also here I must caution, science alone does not make policy. There are many values and political consideration that we have to take into account to get our message across. And one nature of policy, the science policy nexus is policy is rarely determined by evidence, but policy can be and should be informed by evidence. So what are the inputs into policy? One is the science, the evidence, the possible solutions, and the impact. Then there's also political opinion, which you should not ignore. Political ideology, electoral contract, fiscal objective and obligation, and diplomatic issues, and any international obligations. And what is evidence, of course? Don't you think that science is the only source of evidence? We know from our life that evidence will come from tradition or prior belief, local knowledge, which is gaining in importance, in particular the indigenous peoples and local knowledge, anecdote and observation, and lastly come science. We must also realize that data does not equal information. It does not equal knowledge or evidence. It's more than that. So in policy making, often has mixed and not always clear objective. It is impacted by many externalities. So it is about making choices between different options, different stakeholders in different ways with different consequences, many of which are not certain. So virtually all policy making carries complexity, risk, and uncertainties. But perception of complexity, risk, cost, and benefit vary between stakeholders. And eventually the political perspective of stakeholder effects are also need to be considered. We always have this myth of policy making. We thought it's straightforward. We thought it's linear. But ladies and gentlemen, it's not. It's not only about awareness raising, defining the problem, identifying the options, and eventually making the selection. The reality of policy making is more complex. This is what complicate the issue, this is what how you would find yourself in, you know. So the scientists, besides your own views, you'll be moderated by the private sector, the public, the lobbyists, and the policy analysts. And when you reach the government or the political leaders, policy decision here, you would have gone through all this complexity of processes, which makes it sounds complicated, but it's not really. So questions that the policy audience will always have: why do we have to do something now? Why do we need to respond, say, to climate change? Why is it a priority? Have we got the option that meets our broader needs? Then we ask, who will benefit? Who want it? Does it benefit priority stakeholders? What are the risks and to whom? And what is the political risk of doing or not doing? And eventually, what will it cost? So let's look at the scientists, okay? Here's looking at ourselves. We are good at problem definition. Many times we're very good at public advocacy, but less so at finding workable, scalable, and meaningful solutions. And they often approach the policymaker with considerable hubris, you know. And we, the scientists, that is the perception of the policymakers and others, do not understand the complex processes of policy making. Sometimes we have difficulty in taking a multidimensional or multidisciplinary perspective. Remember earlier on I showed the three pictures of climate change, biodiversity loss, and microplastic. Those are not, those have to be approached in a multidimensional and multidisciplinary perspective, not by the engineers, not by the chemists, not by the biologists, but also not just the natural sciences, but also the social sciences and the humanities. You will find that in many cases, science cannot provide the solution without the assistance of the social scientists and humanities. We're talking about change, transformative change, and scientists don't have that, you know. Okay, but again, as I stressed at the bottom, the scientists still have critical roles in the policy process. The challenge of science at the policy societal nexus. Sometimes too much science. When we know science would change from time to time, then there is, of course, many perspective here, different perception of risk, different perception of expertise. These are just trying to confuse you more. But let us look now at the policymakers. You know very well, in particular, politicians have limited bandwidth and often limited maneuverability. I'm talking about the 5-year span of politician. They want to get elected. You know. How sound is your science advice? If it doesn't benefit them politically, they're less inclined to listen to you. They are, as I said, constrained by electoral, fiscal, and other consideration. They lurch to problems often driven by externalities. And we see this if there are catastrophic, tragic occurrences like flood and all that. They'll be there, but only for a while. Yeah. So the policy cycle is generally very short and getting shorter. At the same time, much relevant science is incomplete and sometimes ambiguous. And the policy makers may see scientists as good at problem definition, but not at pragmatic solution finding. I have an anecdote here. When I was science advisor to the PM, he wanted me to establish a science advisory council for him. But he said, I don't want you to just confine it to the members of the National Academy. I looked at him and he said, you guys are more theoretical than practical. So, because I'm working for him, I developed a council comprising of fellows of the national academies, but captains of industries, NGOs, former politicians. So it's a mixed group. And the result was quite electrifying. That's the kind of structure eventually I hope a lesson to be considered during your meeting, how that council should constitute not only the brilliant minds of the academies, but beyond. Yeah. What else? So again, here you must appreciate that these policymakers cannot be expected to be scientific referees. They're not scientists. So we must hold our own. All right. So let's move on. Barriers of the policy side. More of the same here. I just want to impart the fact that one of the dynamics of science advice is not to confine ourselves into silos. Silos may even on the disciplinary scale between the different scientific endeavors. Silos can also be between organizations, between ministries. And scientific silos and policy silos are more or less the same. And of course, time and again, we notice that the policy side has a lack of understanding of the scientific process. Let's move on. This is just to summarize different roles in a science advisory ecosystem. So obviously, there are many stakeholders here, and you can identify with who we are, whether we are individuals, academics, or we are the knowledge generators, the knowledge synthesizers, but we are not the knowledge brokers. So for you to gain a footing with the political masters, you need these so-called knowledge brokers. You can even be one of them, of course, if you try to understand, if you try to be the bridge. So in this table here, we show the different roles of the different stakeholders. In some countries, like my own, we already have one mechanism called the All Parties Parliamentary Standing Committee on Science and Technology, where parliamentarians, ministers, NGOs, what have you, constitute that. Very democratic. But eventually, this mechanism too may not be 100% foolproof, because there are other on the higher up, the ministers concerned, the Minister of Science, and eventually the Prime Minister or President. They are the guys who call the shots. So in a way, for the scientists, there are two types. One is the so-called issue advocate, the scientists who collect, present data with a view to servicing a cause. But to be credible, I think scientists should try to be the honest broker, person who try to identify and overcome biases, to present what is known, what is not known, and just lay it out, the various options. Is not for us to advocate. In other words, there's a phrase for that, for the scientists. Our advice shouldn't be policy prescriptive. It should be policy relevant. So you can present your options. If they are not taken, you would have done your job. It's not for us to talk down to the policymakers or politicians to do this and that. That's not our business. That's the fastest way to be gotten rid by these powers that be. So this is just a purpose of evidence. I don't need to go through that. Uh, there are some lessons here. Uh, we may not have time to go through this, but there are so-called reports, which again, National Academy of Sciences are very good in doing. But the question is whether it is being taken or not. In many cases, good glossy reports are being put out, but they are not fully read by the target group. Again, there would be a problem. Defining the problem is critical, of course, and you have to identify the customer, the policymaker, because the policymaker doesn't have the same frame of mind as the academic. So we need to examine how we align ourselves to the priorities of the policymakers or the country's policy. Another lesson is timing is everything. And here, when you would give the advice is also crucial. It has to be relevant in terms of context and timing, you know. And one thing we must also appreciate of the policymakers or the stakeholders, don't underestimate the value of stakeholder analysis. We must understand the impact of each stakeholder and their influence, and eventually recognizing the different perception of risk and precaution, cost and benefit. Lesson 5, provide practical and scalable option. Policymakers will generally not pick up a problem unless there is a solution. It is rare for problem definition alone to change policy. My earlier point on this, yeah. All right. So finally here, writing report is also part of science advice. Writing a report is not impact, okay? Many academic reports never get read. I think you would tend to agree with me on that, you know. To have most impact, the report must appeal to multiple audiences. Of course, style matters. Uh, avoid jargon, you know. And once the issue has been submitted, we ensure the key audience understands that they would follow up. Do other stakeholders understand? Is there a need for public relation, or is there a need for further action? So in other words, from this slide, just saying that uh, producing a report is not enough. You have to follow up and make sure that some of the recommendations are being picked up. Finally, some final tips for academics, for academia reaching into policy. You must understand the context and challenges of policy making, understand policy processes. When you advise, we must advise with humility and trust, and do not overload the policymakers or politicians with information. And again, as I pointed out earlier, we would want to be an honest broker, right, rather than issue advocate. Find the right time to act, find pragmatic, acceptable solutions, and make friends with the policymakers and understand their perspective. And finally, ladies and gentlemen, science advice is not only confined to the national level, it's also on a regional basis, but also globally. All those negotiations on climate change, biodiversity loss, plastic pollution, the fourth industrial revolution are really international and multilateral in nature. And this goes to the link between knowledge and diplomacy. And in fact, Chair, what we're doing here these 2 days is really a manifestation of science diplomacy, when countries sit down and exchange views and eventually will develop some good common position. Just to leave you with the INGSA, International Network for Government Science Advice, which Remy Couron had highlighted yesterday, is part of the reconstituted International Science Council. We now have 4,000 members from 80 countries. I would urge countries here to be part of this INGSA. There's a lot to be gained actually. And this is a picture of the INGSA Asia, which Peter Blackman of New Zealand, Sir Peter Brookman, yeah, forgot his name, launched in 2014. So with that, let me conclude my presentation. Thank you again. Thank you.
Thank you very much, Professor Sagri.